Alright, so chi has the standard normal distribution, and we want to apply the theorem to get upper and lower bounds of the probability that chi is greater than or equal to 4. Which I think is how we usually phrase this, but anyways. So this is basically just making sure that you understand how to apply theorem 1.2.3. And so basically... So recall that probability that chi is greater than or equal to 4 is given by the integral from 4 to infinity of f of y dy, where f of x equals the density function for the standard normal distribution, which is given by 2 pi to the minus 1/2 times the exponential of minus x squared over 2. Okay. So applying theorem 1.2.3 with x equals 4 yields. Now, theorem 1.2.3 gives bound on the integral from x to infinity of f of y dy. And so we just plug in x equals 4, and we figure out what we get. So we get 4 to the minus 1 minus 4 to the minus 3 times the exponential of minus 4 squared over 2 is less than or equal to the integral from 4 to infinity of the exponential of minus y squared over 2 dy, which is less than or equal to 4 inverse exponential of minus 4 squared over 2. So from here, all we really need to do is first we can do some algebraic simplifications. So let's go ahead and do that. The 4 to the minus 1 minus 4 to the minus 3. 4 to the minus 1 is obviously a quarter, but 4 to the minus 3, I don't want to have to deal with that. But here we get minus 16 over 2, which is minus 8. This is less than or equal to the integral from 4 to infinity exponential of minus y squared over 2 dy, which is less than or equal to 1/4 e to the minus 8. And now, in order for this to be the probability that chi is greater than or equal to 4, we need the integral of f of y, and not just the exponential of minus y squared over 2. So we need to multiply by 2 pi to the minus 1/2. And so what we end up with is we get 4 to the minus 1 minus 4 to the minus 3 e to the minus 8 times 2 pi minus 1/2 is less than or equal to integral from 4 to infinity. And now we've actually got the function f of y dy is less than or equal to 4 inverse e to the minus 8 2 pi to the minus 1/2. Alright, and yeah, that's all that we need. These are the upper and lower bounds that we have on, because this thing is equal to probability that chi is greater than or equal to 4. And so yeah, that's all we need to do for this problem, and so we're done.